Hi, this is Manu from Polyga, and I'm going to show you how our latest 3D camera, the V1, can be used for industrial computer vision applications. The V1 is a high-resolution, high-speed 3D camera that is used in pick-and-place application, surface inspection, medical imaging, and automated part inspection. The V1 comes with our own C++ SDK, and I will be using our SDK along with OpenCV in Visual Studio 2019. Now, brace yourself as we go into transport to the world of programming. What I have here is one of our C++ project examples, which is included in our SDK. This project example is simply written to take simultaneous scans and output the data in real time. With the V1, it is possible to capture up to 15 frames of point cloud data for every 1 second. The data that needs to be used here is a depth map. Depth map is an image or an image channel that contains information related to the distance of surfaces of seen objects from a viewpoint. I have already added the OpenCV library, and the next step would be to change the camera exposure and projector brightness. This needs to be adjusted depending on the objects that is being used. For dark colored objects, you would need higher exposure, and for light colored objects, lower exposure would need to be set. On scan captured is a callback function when a scan is captured, and out depth is a variable that contains a depth map. What I've done here is that I've used the mat class, which is basically a derived class in OpenCV library to store values of images. CV_32FC3 defines the type of matrix in the mat class. Here, it means that 3-channel matrix of 32-bit floats will be stored. Now that we have the X, Y, and the Z in the mat class, the OpenCV split function can be used to split and store them individually. With these data, it is now possible to write functions for pick-and-place applications, flaw detection, and feature measurements. The function detectCircle essentially detects circular objects. This is a very basic but classic example of pick-and-place application. The OpenCV function HuffCircle can be used here to detect circular objects. The minimum and the maximum radius of the circle that needs to be detected can also be predefined here. I have the V1 connected to the computer, and I have a bin full of random objects within its field of view. If I call this function, the circular objects is detected, as you can see from the live feed. The bin can also be moved sideways, and V1 should still be able to track the object. It is also possible to use the data, the depth values, to measure the radius of the circle in real time, and this can be done for other objects of different sizes and shapes. Now, to give an example of flaw detection application, I will be using the function detectEdges. Using Gaussian blur and canny edge detection, I will be able to find the outline of objects. In this example, we will be using 2 boxes of different sizes. This would be very similar to a go or a no-go situation in an automated inspection line. Using X, Y, and Z coordinates, the dimensions of the box can be measured in real time. I hope some of these examples have given you an idea of what the V1 is capable of. If you did like the video, please like and subscribe to our channel, as we will be adding similar contents in the future. Also, if you have any questions, feel free to reach out to us at contact@polyga.com.